All right, this is part 1 for screencast for Module 1, Lesson 2, where we are going to start modeling quantities. And the essential question is, how can you use rates, ratios, and proportions to solve real-world problems? Well, let's first talk about what a ratio and a proportion, what those two things are, because they can be very useful in solving real-world problems, as it says down here. And that's kind of a hard thing to say, real-world problems. Okay, a ratio is a comparison of two numbers by a division, like a fraction looking thing. An equation that states that two ratios are equal is a proportion. Okay, so we're not going to waste any time. We're going to get right to an example. It says a totem pole that is 90 feet tall casts a shadow that is 45 feet long. At the same time, a 6-foot tall man casts a shadow that is X feet long. The man and the totem pole are both perpendicular to the ground, so they form right angles with the ground. The sun shines at the same angle on both, so similar triangles are formed. Okay, so basically they're saying here is a triangle, here is a similar triangle. Remember, similar triangles have angles that are the same and sides that are proportional. Okay, so step A is to write a ratio of the man's height to the totem pole's height. All right, so let's do that. Okay, so man's height over totem pole's height. Then it says to write a ratio of the man's shadow to the totem pole's shadow. Man's shadow, totem pole's shadow. And then write a proportion. So man's height over totem pole's height equals man's shadow over pole's shadow. So 6 over 90 equals X over 45. Solve the proportion by multiplying both sides by 45. Okay. So you multiply both sides by 45 to get rid of the 45 in the denominator over here. So you wind up with 6 times 45 over 90 equals X. And when you do all that math, you wind up with 3. Now, the other thing that you might have noticed is when you do this proportion, 6 over 90 is equal to X over 45. If I take this number 45, I might notice that 45 times 2 is 90. So whatever this number is times 2 is going to give me this number. So 45 times 2 is 90. X times 2 is 6. So X must be 3. So that's another way you can kind of think of it. Okay, so on number 1 discussion, it says, what is another ratio that could be written for this problem, and use it to write and solve a different proportion to find the length of the man's shadow in feet. Okay, so the first go around, they did the big model or the big item, and they said height over shadow, and they set that equal to the little thing's height versus shadow. Okay, but you can also do like big height over little height equals big shadow over little shadow. It's just you can't mix and match. So another way to do this would be 90 over 6 equals 45 over X. Okay, which is basically going to give you the same thing as up here. Also, as long as you make sure you don't mix and match, you could do height of the big item over its shadow equals height of the little item over its shadow. Okay? It's just you need to make sure that you don't wind up with anything like catty corner or whatever. Okay? So like over like, and set the proportion up accordingly. All right, I'm now on page 16, and now we're going to talk about scale drawings, which is really, we're still using ratios, but this has a particular application. So a scale is the ratio of any length in a scale drawing or scale model to the corresponding actual length. So a drawing that uses a scale to represent an object as smaller or larger than the original object is called a scale drawing. If you've ever seen like house blueprints, that's a scale drawing, okay? Because you've represented an entire house on a little piece of paper. A three-dimensional model that uses a scale to represent an object as smaller or larger than the actual object is called a scale model. So think of like your little Hot Wheels cars. If you go to Walmart and buy a little Hot Wheels car, it'll tell you the scale. Like that little Hot Wheels car is, I don't know, 1/24th the dimensions of the actual car that it represents or whatever. Okay, so that would be a scale model. Okay. Use the map to answer the following questions. Okay, so here's our map. Notice we have a scale. 1 inch is equivalent to 18 miles. The actual distance from Chicago to Evanston is 11.25 miles. What's the distance on the map? Okay, so first of all, we're going to write the scale as a fraction. We're going to say distance on the map over actual distance. Distance on the map is 1 inch. Actual distance that it represents is 18 miles. Okay, so 1 over 18 is equal to whatever the distance is on the map, because that's going to be equivalent to 11.25 miles. Okay, notice the 11.25 is in the denominator, so we're going to multiply both sides by 11.25 to get rid of it here. Now on this side, all we're left with is d, and they said 1 times 11.25, so now you have 11.25 divided by 18, and there is your distance on the map. It's about 0.625 inches on the map. Okay. Actual distance between North Chicago and Waukegan, I guess, is 4 miles. What's the distance on the map? Okay, so again, map over actual. 1 inch is 18 miles. Let D be the distance on the map. So 1 inch over 18 miles is equal to whatever distance on the map, which is equivalent to 4 miles. Multiply both sides by 4. Okay, and that's what they did over here. So 4 times 1 is 4 over 18. And rounding it off a little bit, you get 0.2. So the distance on the map is about 0.2 inches. Okay? A scale model of the human heart is 196 inches long. So this time they're making it bigger than it really is, because your heart is not actually 196 inches long. Okay? So it must be maybe a big display or something at a museum. Okay? 196 inches. The scale is 32:1. Okay? All right, so what that means is 32 inches on the model is equal to 1 inch on your actual heart. Okay? So we're just going to put these together. 196 inches on the model is how many actual inches if the scale is 32 inches for the model, which represents 1 inch. Okay? All right, and then this time what we're going to do is, let's see, well, I don't really have to multiply both sides by 1. I get 196 over x equals 32. Let's get x out of the denominator. Get 196 equals 32x. Divide both sides by 32. 196 divided by 32, and you get 6 inches. Okay? You could have very easily said 1 inch on the heart is 32 inches on the scale. So that's x inches long for the heart, because that's 196 inches on the scale model. And you wind up, you multiply both sides by 196, which means over here you're still doing 196 divided by 32, and you're still going to wind up with x is equal to 6. So either way. Okay? Like I said, as long as you are pairing things up correctly, your proportion will work out just fine.